An article in Power Engineering has me excited about electrolytic hydrogen. I'll go through the article and give my thoughts on today's Hydrogen Podcast.
So the big questions in the energy industry today are, how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast.
In an article in Power Engineering, Manuel Hernandez and Ahmed Wafi write, Reimagining Green Hydrogen, Empowering Progress Through Digital Solutions. They write, with renewables becoming the linchpin in our economy's energy transition, organizations must continue to find sustainable solutions for the sake of the planet. While electrification and renewables are the most optimal vector for decarbonization, hydrogen has grown in popularity as a viable decarbonization solution for hard-to-abate sectors. Its versatility and ability to store and transport energy make it a promising option for industries such as heavy transportation, aviation, and certain industrial processes that face unique challenges in reducing their carbon emissions. By embracing hydrogen as a decarbonization tool alongside electrification, we can ensure a comprehensive and effective approach to achieving a sustainable future. For decades, hydrogen has held a fundamental position in various manufacturing processes. However, the emergence of green hydrogen is rapidly transforming it into a crucial resource for propelling industrial operations toward a carbon-free future. Considering the urgent need to halve global CO2 emissions by 2030, the role of green hydrogen becomes even more critical in meeting both industrial and environmental imperatives. Green hydrogen, produced through electrolysis using renewable energy sources, offers a sustainable solution to address the challenges of reducing carbon emissions in industries. The potential of green hydrogen to revolutionize industries and contribute to a sustainable future is undeniable. Together, we can accelerate the market adoption of green hydrogen to make a way for an industrial landscape that mitigates climate change impacts and drives sustainable growth. A few figures illustrate the magnitude of hydrogen's contribution to today's greenhouse gas emissions. Currently, we're producing 70 to 80 million tons per year of unabated hydrogen obtained by steam methane reforming of hydrocarbons, but the way CO2 is released directly into the atmosphere. Every kilogram of such unabated hydrogen produces 12 kilograms of CO2, for a total of close to 1 billion tons, or possibly 5% of total global emissions every year. About 33% of this hydrogen is then dedicated to industrial gas applications, with the remaining 66% going towards refining and chemical production. As industries continue to use hydrocarbons to power their production, electrification is a viable option for reducing related carbon emissions and improving efficiencies. However, this option is not always feasible due to technological limitations, infrastructure constraints, or energy-intensive processes. This leaves a significant demand for processes or segments that can't be powered by electricity alone. That's where green hydrogen will become essential. By utilizing green hydrogen as an alternative, it can replace natural gas and deliver enormous savings in emissions. The versatility of green hydrogen allows it to serve as a reliable clean energy source for industries, transportation, and heating, where electrification may not be a practical solution. By incorporating green hydrogen into the energy mix, we can make substantial progress in decarbonizing sectors that were previously challenging to abate, ensuring a more sustainable and environmentally friendly future. However, commercial-scale production of green hydrogen has a few challenges and risks. For large-scale use, developers and operators need to pay close attention to production and operations to ensure plant economics can support this much-needed transition to adopting green hydrogen. To accelerate production, developers need to consider the entire value chain at the plant level. The overall architecture for a green hydrogen plant site consists of the following: power generation, including a renewable energy source such as wind turbines, solar panels, battery electric storage systems, and grid connections enabling bidirectional power flow. Number 2, the hydrogen production unit, which includes a water treatment plant, electrolyzers, separators, and other production-related equipment and systems. And number 3, downstream hydrogen unit, which utilizes the produced hydrogen, like ammonia production, pipeline injection, cavern storage, or mobility fueling stations. In all 3 aspects of this architecture, optimized control is imperative to ensure 1. Reliable integration of power supply resources to guarantee production. 2. Production maximization based on available power and electrolyzers. And 3. Maximized utilization of available hydrogen with optimized conversion rates. An integrated production system oversees and coordinates this entire value chain with capabilities that include renewable power forecasting, electrolyzer production optimization, overall efficiency monitoring, and operations simulations. A unified enterprise control system can be deployed for control of a centralized operations center for multi-plant operators. As an emerging technology, green hydrogen production brings some challenges for project developers and owners. Industry leaders need to address key improvements to make projects on track and profitable through their operation, along with solutions to ensure their partners' success, including, number 1, increase cost competitiveness. Both initial CapEx and ongoing operational expenditures figure into the levelized cost level of the green hydrogen a plant produces throughout its lifespan. For lower CapEx, organizations need to optimize energy management and process automation to shorten ramping up periods. For lower OpEx, companies must optimize energy sourcing, increase system efficiency, and maximize annual full load hours of electrolysis systems. Number 2, de-risking introduction of technologies. To help minimize risk with this new technology, safety instrumented systems can offer a unified system to control process operations and energy consumption. Having a training and simulation platform will also help facility operators explore what-if scenarios in a safe digital environment. Number 3 is supply chain optimization, facilitating the use of digital twins to enable predictive simulations of power and production availability will optimize supply chains. Facilities will be able to manage their energy supplies to optimize renewables while minimizing costs and uptime. And number 4, collaboration and knowledge sharing. Collaborations across industry players, research institutions, and governments is key to overcoming challenges in green hydrogen production. Sharing best practices, technical expertise, and lessons learned fosters innovation and accelerates the development of cost-effectiveness and efficient solutions. Collaborative initiatives can also facilitate standardization, certification, and knowledge dissemination, promoting the global adoption of green hydrogen technologies. And by focusing on those aspects, project developers can navigate the challenges and unlock the full potential of green hydrogen as a sustainable and decarbonized energy solution for the future. The investment in green hydrogen solutions may be expensive, but the long-term benefits of this renewable option are hard to turn down. By implementing the right architecture with the right solutions at the right time, we can pave the way for a decarbonized future. Okay, so I've read a lot of articles on the benefits of green hydrogen. This thought piece may be one of the best I've come across in addressing green hydrogen plant economics at the development level. And I know I'm not alone in appreciating how Manuel and Ahmed laid out basic but effective ways to lower green hydrogen plant OpEx and CapEx, as well as de-risking pre-construction plant economics through the use of digital twin technologies and other systems for pre-development modeling. And I've gone into the use of technology several times in the past, and it is a vital piece of the puzzle. But I'm also extremely appreciative of number 4 in this list. Collaboration and knowledge sharing will be critical for the hydrogen industry to grow at the pace it needs to be cost competitive with legacy oil and gas before 2050. I know many of us would rather keep all of our in-house developed knowledge a trade secret, but that mindset may not make for the best returns. Now, I'm not saying by any means make what you're doing open source. Proprietary technical information should be guarded. But as plants spin up and agreements become established between operators, offtake, and transformation and transportation, Let's work together to break down certain barriers. This high-level knowledge sharing will be an effective way to both increase demand and reduce governmental policies that could hinder hydrogen's development. All right, that's it for me, everyone. If you have a second, I would really appreciate it if you could leave a good review on whatever platform it is that you listen to. Apple Podcasts, Spotify, Google, YouTube, whatever it is. That would be a tremendous help to the show. And as always, if you ever have any feedback, you're welcome to email me directly at info@thehydrogenpodcast.com. So until next time, keep your eyes up and honor one another.
Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.